All right, in part 2 of Chapter 17 lecture, we're going to talk about the approaches to sampling for balances. Now, there are two primary, as I said in part 1, there are two big methods that we typically cover in the semester of audit, and that's variable sampling, of which there are three types: difference estimation, ratio estimation, and mean per unit. And then there's monetary unit sampling. And we focus on difference estimation. I think it is the most widely used, although I have heard of mean per unit being used quite often as well. I've not seen personally anybody use ratio estimation, but it's certainly a possibility as one of the methods for variable sampling. So we're going to focus on difference estimation, and then I'm going to post some slides and probably a short lecture on monetary unit sampling, just because I don't want you to get shortchanged in this kind of shortened semester here. So difference estimation, you can read there, measures the total estimated misstatement in a population when there is a recorded value and an audited value for each item in the sample projection. And we will do this by account. And what ends up happening, the reason we call this difference estimation is because we have this netting effect. So we will be selecting a sample of items to test for misstatements. So again, let's use AR, accounts receivable, as an example. So we send out 100 confirmations. We get, let's just take a really positive assumption here and say we get all 100 of them back. And there's, let's just say there's 8 of them that have misstatements, 8 out of 100. Now, obviously with accounts receivable, you would have the expectation that you would find more overstatements than understatements, but it's possible that you would find both. And so difference estimation essentially is what we will be doing is calculating the difference between what was recorded and what should have been recorded, right? So we have a recorded value and we have an audited value, what it should have been. And we'll take the difference between the two. And we do some sort of a netting, right? We will net the over statements against the understatements, and then we'll get a point estimate. And that's the way we do difference estimation. And monetary unit sampling works quite different. But let's try difference estimation first here. So here is statistics. This is from your statistics class. Hopefully this formula looks relatively familiar to you. But you remember when we calculated confidence intervals, we would take an X bar, we would take a mean of a sample, right? We'd take a sample and calculate a mean within that sample, and then we would project that mean onto the population to see if we could come up with a population mean. So we would take the mean of the sample, which is X bar there, and then we would add and subtract this kind of, essentially what it works out to be is an allowance for sampling risk. So the standard deviation divided by the square root of the sample size multiplied by some z-stat. And adding and subtracting that to the mean of the sample would give us a confidence interval. You know, a 90% confidence interval or a 95% confidence interval. So this is a statistics formula that you should, again, be relatively familiar with. And in accounting or in auditing, all we do is adjust this formula slightly. And so this is essentially what we will do in audit. And yes, it does look a little bit more frightening. I would not have you memorize this. I would give you this formula. So it's never anything that you, in fact, nowadays it's all built in the computer software that you would use in a real audit environment. But this is the formula that's happening in the background. So what ends up happening is we have the E bar will still be the average of the error. So that would be the summation of all of the errors that we find in our sample, right? It'd be the netting against overs and unders. We'd multiply that by the population size to get a point estimate. And then we would plus or subtract, add or subtract what we call in audit the computed precision interval, or the CPI. And you can see that that formula there looks very familiar to what it was in stats, right? Population size times standard deviation divided by square root of sample times some z-stat. And the z-stat there is essentially what we would call our area, acceptable risk of incorrect acceptance. And it's typically a z-stat, at a 5 or a 10% area. So it's not that much more complicated. And again, you'd never have to memorize that. So let's see how it works here for an example. Let's just say that we set a few things based on our judgment, that area is 2.5%. Now you have to understand that this is a area of 2.5% gives you 2.5% in each of the tails, right? So we're basically going to have 2.5% on the overstatement side, 2.5% on the understatement side. So we end up with a 95% interval here, right? And then the area, acceptable risk of incorrect rejection, is at 100%. And that, quite honestly, guys, is only used, the area number is only used in our sample size calculation. So it's really not important on the test itself, only in the determination of the sample size. And we're going to set tolerable misstatement at $40,000 for both overstatements and understatements. So these are all things that we would set prior to doing any testing. And so we're going to be testing accounts receivable. The sampling unit is going to be customer accounts. And we have a sample size of 100 out of a population of 25. And we find 5 errors in our sample of 100. And there are the 5 errors. So you can see we've got, looks like we have 3 overstatement errors and 2 understatement errors. And so what we do is we sum those up to get a total sample error. And so $582 is the netting, right, of the overs and unders. And so what we do is we'll take that, right, our E bar will be the total, the sum of all the errors, 582, divided by our sample size. Remember, we had a total sample size of 100. Even though we only found 5 errors, our total sample size was still 100, so our E bar is $5.82. So what that means is the average error, right, for all of the sample items is $5.82. To get E hat, again, we take the population, we have 2,500 accounts, times the average error, E bar. And so our point estimate there is $14,550. So that's the point estimate for the population. So we're saying that the population has an estimated misstatement of $14,550. And that's all based on known errors, right? $582 of known errors, and then just projecting that onto the population. That does not take into account, right, any risk associated with maybe a non-representative sample. So now what we need to do is add and subtract that precision interval. So I would give you the standard deviation. I would never ask you to calculate a standard deviation manually with your calculator, so I would give you that. And so now we do this computed precision interval, and you can see the formula there. Again, you would never have to memorize the formula. The things that I want you to recognize are, first of all, this 1.96, right? That should kind of jog your memory from stats class, as the z-stat for a 95% confidence interval was 1.96. So this corresponds to just your typical statistics class. When we're done with this, we'll have a 95% confidence interval, essentially, 5% split between the two tails, 2.5 and 2.5. So that z-stat should look familiar there. And then we just drop in all the numbers, right? Population size, standard deviation, sample size, and then the calculation over here as well. And so to get our upper confidence interval, we'll take the point estimate of the error, the E hat, add the computed precision interval, and so we get the highest estimate of the misstatement in the account is $41,412, and the lowest estimate of the misstatement in our account is negative 12,312. So they're saying, look, guys, we're 95% certain that the misstatement in this account is somewhere between an overstatement of 41,412 and an understatement of $12,312. That's a pretty big range, but again, we want to be very certain. So we're 95% certain that it's somewhere between these two numbers. And so what do we conclude? Well, you have to remember that our tolerable misstatement was $40,000 for overstatements and $40,000 for understatements. So if our highest estimate for overstatement is 41,000, right? That's clearly more than what we can tolerate of 40,000. So at the end of the day, we're going to have to conclude that this account is materially misstated. So let's just look at this from a graphical standpoint. You can see here, there's our point estimate of the error, that E hat, right? 14,550. There's our upper misstatement bound. There's our lower misstatement bound. 2.5% in the tails, and so we're 95% certain that it's somewhere in the middle here, right? And remember, let me go back just so you guys can take a look at that for a little bit longer and just read through that, right? 95% confident the misstatement is in this range. There's a 2.5% chance that it's misstated by more than 41,412, and there's a 2.5% chance that it's understated by more than negative 12,312. That's what these tails mean. And so when we look at it again, we see that our tolerable misstatement was 40,000. That's inside the bounds, right, which is a bad thing, right? We will conclude that this account is materially misstated. And so the statistical, remember the whole point of using statistics in auditing is so that we can quantify the risk, right? Remember in the tail here, there's a 2.5% chance from this line, there's a 2.5% chance that the misstatement is higher. Well, if our tolerable misstatement is inside the bounds, we say that there's more than a 2.5% chance that the account is misstated by more than $40,000. That's our statistical conclusion where we've quantified the risk, right? There's more than a 2.5% risk that the misstatement in the account exceeds $40,000. Again, 2.5% is exactly that line. So if we come to the left of it, we say that there's more than a 2.5% chance. Now, if my tolerable misstatement was 50,000, right? Obviously, my line would be way out here in the tail, and so the statistical conclusion would be there's less than a 2.5% chance, right, that the misstatement in the account exceeds $50,000 if 50,000 were my tolerable misstatement. And also notice, guys, that we set an understatement tolerable misstatement of 40,000, which would be way out here in the tail. So there's very little chance that the account is understated, right? But because one of the tolerable misstatements was inside the interval, our overall conclusion is that it's, right, materially misstated and most likely materially overstated, not understated. Now here's the formula for sample size. I've never asked historically to calculate a sample size using variable sampling or difference estimation, and you can see there's where that z-stat for arrear is. And again, this is just a formula where we can statistically or probabilistically calculate a sample size using difference estimation. And I think that's about it for that as far as sampling. How is the sample chosen? Remember all those probabilistic sampling techniques we talked about back in attribute sampling. We would have to do it randomly or with an interval with a random start point, those types of techniques. So this is an important part of Chapter 17, is just kind of going through and figuring out, well, what happens to sample size if I increase AREA or increase tolerable misstatement or increase the population size. Effectively, so here's the answer, and you guys can work through these to figure out why if you increase AREA, you decrease sample size, or increase AREA, you decrease sample size. if you had this formula on the prior slide here, right, all you have to do is plug in numbers, and right, so increase area, right, that's in the numerator, higher number on the numerator would, keeping everything else constant, right, would make that n go down. So you know, you just have to work through the math there to kind of see how these variables would impact sample size. I think that's an important aspect of understanding how sample sizes are impacted by changes in some of the variables that we judgmentally select. All right. And I think that's the end for, it says end for sampling of balances, but it's really just the end of difference estimation. And I'll post another lecture here in a second related to monetary unit sampling.